Hi, the following video is a compilation of all the research SolVaCov has been developing in the first sprint of the project. This sprint emphasized in the acknowledgement of the problem and its context. It was also a stage in which the team looked for current solutions and brainstormed new ones, followed by a rigorous but not exhaustive evaluation of these to determine which alternative fitted the best given the established criteria. Last year, the World Health Organization approved the distribution of COVID vaccines. Although these vaccines are manufactured by different companies, some of them must be transported and stored at low temperatures, others at ultra-low temperatures ranging from -20 to -70 degrees Celsius. After the government announced the arrival of the vaccines at the start of 2021, health entities started to look for ways to adapt the expanded program on immunization to the new vaccine. Now, this is where SolVaCov comes into play. The main task is to develop solutions that support the transport of vaccines in a way that guarantees the cold chain. Before continuing, it is worth noting that the team plans a solution capable of keeping the vaccines at temperatures between 2 to 8 degrees Celsius for 5 days. After studying the challenges involved in the context, the team looked up for potential audiences that fell into a special set of needs. The first is the municipality of Nueva Granada, Magdalena. After analyzing meteorologic and vaccination coverage maps and the set of news from the area, the team discovered that Nueva Granada may be a user to the solution due to its daytime temperatures reaching to almost 40 degrees Celsius and a tight resources relating to electricity. On the other hand, there is the municipality of Arboledas, Norte de Santander. Here, the road access is limited and prone to obstructions that may leave nearby towns inaccessible for hours, even days, due to unforeseen events. Stated the potential users, the team defined a set of requirements and criteria that encapsulate the best solutions possible. Some of the requirements are: the solution must be energetically autonomous. The solution can be transported by foot. The solution must operate between temperatures of 2 to 8 degrees Celsius. Past that filter, the team proposed criteria relative to the user needs. For example, the possibility to absorb vibrations and achieve an optimal interior to exterior volume ratio. Moving on in the design process, the team now had to come up with a variety of alternatives to attack the problem. These alternatives were divided into two main groups: active systems and passive systems. In the active system, the team proposed two alternatives to a solution. The first one involved a portable compression refrigeration system powered by a lithium battery. This concept was prototyped using sketches. On the other hand, members of the team worked on a thermoelectric refrigeration system using Peltier cells and solar panels to feed a battery when needed. Now, the passive systems team came up with two alternatives. The first being a system that included eutectic phase changing materials, or PCM, designed to place a specific number of doses and integrated with a damping system to protect them from vibrations. The second alternative involved organic PCM with a totally different packaging design compared to the last alternative. These concepts went through an evaluation process that included a variety of indicators ordered in the level of importance, such as capacity, materials cost, weight, damping, stackable geometry. The best alternative according to the evaluation was the active system involving Peltier cells and solar panels due to its low weight, followed by the PCM alternatives and the compression refrigeration system. This result helped the team to come up with the definitive concept of the sprint. The system is divided into two subsystems: refrigeration and isolation. The first covers the circuits that interact with the cells and the active section of the refrigeration system. The isolation system covers the geometrical aspect of the solution and focuses on the inclusion of alternative materials. We expect to refine the solution for the following sprint, especially its functional aspect. In addition, we're looking forward to build our first physical prototype and be able to put it to the test. It is important to note that drastic changes in the solution may occur. Thank you for watching.